Divergence theorem. As we
Ma'am, screen is not visible.
divergence theorem. So as we learn already what is the divergence, it is the net outflow of flux per unit volume as the volume shrinks to about point P or 0. Now in divergence theorem, it is a theorem that states that total outward flux of a vector field A bar or any vector field, you can write for any vector field through the closed surface S is the same as volume integral of the divergence of A bar. Now students, this is the very important theorem. Every time we require the divergence and the Stokes theorem, including to study Maxwell's equation or to solve the numericals or to study the applications of electromagnetics. Now here, you know the difference between the closed surface and the open surface. So, closed surface, it is an volume. Open surface is doesn't enclose any volume. Okay, so when there is a closed surface integration, also please try to understand this integration sign. Now this is the integration with this closed surface, and here written it is S. That means it indicates that it is a closed surface. That means it encloses volume, right? So this volume, that means this is the flux definition, right? A bar dot ds bar, net outward flux through any vector A bar. Okay, so what the theorem states that whatever the outward flux of vector field A bar through the closed surface is same as volume integral of divergence of that vector A bar. मीन्स सपोज यहाँ पे मैंने एक बलून लिया, ठीक है, तो इसमें से जो भी नेट आउटवर्ड फ्लक्स है फ्रॉम दिस, दैट इज द फ्लक्स, दिस इज द LHS साइड, and what is the RHS side? Volume integration of divergence of A bar. That means first you find the divergence of A bar, that is nothing but this LHS formula, right? And take the volume integration. That means suppose I divided this part into small different part, okay, and find out the divergence for this divergence, and then I integrated for the complete volume over the dV. That is the complete divergence for this volume. So simple, total outward flux through A bar through the closed surface is same as volume integral of the divergence of A bar. And always remember, closed surface resultant is only volume. If there is one closed length is there, that means it is an open surface. Try to understand the sign conventions in this integration. This is the closed loop, means open surface. This is the closed surface, means volume. So that is the big difference between open surface and the closed surface, right? So this is the divergence theorem. Now, how to prove that? What is the last proof? You have to prove that this LHS side is equal to RHS side, that is the A bar dot ds bar is equal to volume integration of divergence of A bar. Now here, to prove this divergence theorem, okay, in your textbook I think one page proof is given, but this is for from reference book, that is the Matthew Sadiku, and this is the simple proof, that is the for divergence theorem. Okay, just some theoretical statements are there. To prove the divergence theorem, subdivide the volume V, as I already explained that subdivide the volume V. Suppose I am taking the one volume. Okay, subdivide. Subdivide means obviously whatever the volume we are taking, that is the large enough, so we need to differentiate. जैसे हम differential length consider करते हैं, तो इसमें अभी different different surface consider करेंगे हम इसको, ठीक है, to find करने के लिए. V into large number of small cells. If the kth, now how many cells are there? This is the kth cell from starting with 1 to k. Okay, so total वॉल्यूम क्या होगा? डेल्टा वी के. एक सेल का वॉल्यूम क्या होगा? डेल्टा वी के, केथ सेल. ओके, so same मुझे just in terms of k, like a bar dot ds bar LHS side of the divergence theorem is equal to whatever this flux, this is the this means what? Outflow of the flux is equal to, this means what? Summation of this all kth surfaces. So total flux from this surface, nothing but whatever the flux, outward flux from this all kth surfaces. That's why here this is the flux from the kth surface, and ये सारे k surface का summation, that is means total outward flux from this net volume. ठीक है, now need to convert this flux formula in terms of divergence, right? We have a divergence formula, del dot a bar is equal to flux definition divided by delta vk as the limit delta v tends to 0. This is the divergence formula. तो अब क्या करना है? Multiplied here and divide. Okay, that means no change in the equation. So multiplied and divide to this RHS side. Okay. Now, since the outward flux to one cell is inward to the same neighboring cell, obviously, suppose यहाँ पे मैं अभी I'm going to draw this flux. Flux coming out from this cell, center cell, right? This is the flux, outward flux. But for this cell, this is the inward flux, right? So the outward flux to one cell is inward to the some neighboring cells, right? So there is a cancellation on every interior surface. So the sum of the surface integral over the SKs is same as the surface integral over the surface S. That means what is the what this statement tries to say or to convince, that this is the flux for the K surface and complete flux is nothing but the summation of the K surfaces for this total outward flux. So taking the limit delta V tends to 0 of RHS side, because we need to prove this theorem. So according to the divergence theorem, we have to add this limit delta V tends to 0. Delta V, this is the divergence. Here it is, vector is a bar. Now in divergence it is a bar. Okay. तो यहाँ पे मैंने लिमिट पुट किया, तो यहाँ पे लिमिट पुट किया, तो ये डेफिनेशन बन गया डाइवर्जेंस ऑफ ए बार का. तो यहाँ पे ऑब्वियसली दिस ए बार डॉट डी एस बार डेल डॉट ए बार डेल्टा वी, ये लिमिट मैं पुट क्यों कर रही हूँ? बिकॉज यहाँ पे जो सेल है, एक सेल पे जो भी आउटवर्ड फ्लक्स फ्लो हो रहा है, तो ये बोल रहा है कि दिस इज द कमिंग टू द पॉइंट पी, श्रिंकिंग टू द पॉइंट पी. ठीक है, तो उसको मैं लिमिट डेल्टा वी टेंस टू 0 अप्लाई कर रही हूँ. बट मैंने अप्लाई किया तो ये डेफिनेशन बनता है डाइवर्जेंस ऑफ ए बार. सो दैट्स व्हाई divergence of A bar and delta V. This delta V is as it is for the complete. ये सिर्फ है divergence. तो ये हुआ. तो for the considering the entire volume, integrate right hand side over the entire volume V enclosed by the surface S. तो यहाँ पे मैंने इंटीग्रेशन डाला फॉर ऑल कंप्लीट वॉल्यूम, तो मुझे मिला मेरी डाइवर्जेंस थ्योरम. Hence, the divergence theorem is proved. The theorem is useful for the evaluation of volume integral. Is easier than evaluate surface integral. Okay, here the surface integral is converted into the volume integral. This is the very important point of this theorem. Closed surface integral is converted into the volume integral, and hence this is the theorem is proved. Question is always there, state and prove divergence theorem. What are the significance of the divergence theorem?